So I was explaining you f of gx. And this 1, 1. In order to prove 1, 1, you always suppose that f of x1 is equal to f of x2, okay? This way, when you are assuming that your functions are equal, your y values are same, and you are saying at last that no, y's were same because x's are same, and hence it is 1, 1. Are you getting my point?
So the x values are the same?
Yeah, that is what 1, 1 is. When you have only one x for one particular y, right? So you are
Yeah.
saying if your fx1 and fx2, two different y's, right? One is y1, one is y2. If they are equal, so you are assuming with the contrapositivity. No, I am not assuming that it is 1, 1. So what you are saying, let's assume there are two y values, y1 and y2. But I have assumed that both of them are equal. That means it is not the case of 1, 1.
Yeah.
I think I need. Okay, now it should work. I'll change the device. So let's say you have a function fx equals 2x minus 3, okay? And you have to check whether it is 1, 1 or not.
Yeah.
So what you will do, you always assume that your function's value for different x are same. That is, this is not the condition of 1, 1, right? You are saying there are two different y values and you are saying those are same. You always assume that for different x you have same y values. Different x, you have same y values. This is not the condition of 1, 1, right?
Yeah.
But why I'm assuming it, I'll say that it is same because my x's are also same. I'll say that no, this is not actually, this is not a and b. It is actually a equals b. Okay? So understand. I'll explain you later. F of x1, that is, substitute here in place of x, x1, here x2. Is this fine?
Yeah.
This is gone. 2x1 equals 2x2. That means x1 equals x. So you are saying, though I had assumed that y values are same, but this also implies that x values are also same for which I am getting same y values. And that is the condition of 1, 1, right?
Yes.
So every single time for 1, 1, you will assume either you assume this or you assume let y values are not same, and from there you bring this out that x values are also not same.
Okay. So you just use either one of those two methods.
Yes. Yes.
Right.
And
We do
all, huh,
next question from I sent an email that's called Mathematics 1 Calculus Exercises Tutorial 2.
I'll come to that. I also want to tell you one more thing.
Okay.
If you have GOFX and FOGX, and if these are same values giving you x, then that means that function is invertible, and invertible means 1, 1 onto. So this is also one way of saying this. So what you do, you find out FOG. For example, if I have, this is the case when you have two functions and you put the values into each other. And for onto what you prove, you will simply prove that because every y has its unique or its pre-image in X. Hence, the function is onto. Okay? Does this make sense?
Yeah.
Huh. Tell me another doubt. So, in tutorial, which example exactly? Which
Question
question?
1A.
Question one, fx is equals to x square minus 1, gx equals square root of 4 minus x square.
No. F of
I'm,
x equals to x squared minus 4x plus 5.
I,
It's
you
a
share.
document of 11 questions. I sent it to you uh 3 hours ago.
Okay, let me see. Oh, I got it now. Hmm. Which question is it?
Question
Question
1A.
number. Oh, yeah. So it is saying the function is moving from, let me, because it there. Yeah. So I have this question. fx is fx is x square minus 4x plus 5, right? And you have to show that f is a surjection. What do you mean by surjection?
Like it has to be an onto.
Yeah. So for onto, what do we do? You would simply say that y equals x square minus 4x plus 5. Find out the value of x. Solve it. Do you know middle term splitting?
Yeah.
Solve it for x. Tell me what are the roots.
X minus 2 squared plus 1.
Where?
Yeah. Like I did it via the square method.
Yeah. You do this way. 5 ones are 5 and you take LCM. You have to make it 5. So how can you do it? This way, right? Correct? You
Yeah.
have split it down this minus 4x into this. Now you take common, but it is not satisfying.
You
5
just
ones
take
are
x
5.
minus 2 squared plus 1.
Okay, what did you do? X square
X minus 2 squared plus 1.
plus 1. Okay. You did completing the square method, right?
Yeah.
Okay. So this is your y. Now, in order to prove it onto for A0, when the domain is moving from A to infinity, A infinity to 1 infinity, you have to prove the surjection for A0. Now, surjection, I know that every codomain must be having its pre-image, right? Every range should be there. Every codomain should have its pre-image in X. in the domain. Is this correct?
Yeah.
So if you have A0, that is 0 to infinity. You substitute anything, 0 to infinity, anything. This is for x, right? So if you substitute anything like 0, 1, 2, you will find out that it is giving you the range, the answer y belongs to 1 to infinity. See, can there be anything? For example, this is giving you -2, but -2 square will give it positive. The least answer which it can be is this. 2 minus 2 is 0. 0 square is... So it is starting from 1, right?
Yeah.
So you have to prove in order to be on to every x value should give me the y. There should not be any single y which is not defined for any x. So if I am putting anything, be it 1 by root 3, 0.2, 0.5, anything, I am getting, because any negative number which you will get, this will become positive. So it will give me higher values. The least number which I can get, the minimum, is 0 here and 1 here. So 1, because it belongs to this range, hence it is onto. And then again you will write the same definition, that because every range, every single domain is giving the answer which belongs to this range, hence it is onto. Surjective. Does this make sense?
Yeah. No.
Kind of. No. Tell me, see, if I have this limit, if I make the set from it, arrow diagram, there will be values starting from 0 in A. There will be values starting from 1 in B. There will be some 1.1, some root 2, some root 5. Correct?
Yeah.
Now, if I start mapping it based on the function, which is x square minus 4x plus 5. Okay. Now, if I substitute the value, anything from this A can be chosen for x. Correct?
Yeah.
I have simplified it a bit more. Just like you said, the perfect square. X minus 2 square plus 1 will also give me this. So if I have simplified it in order to have it the positive, this will always give me positive value. Any x, any this sort of x taken will give me positive value, right?
Yeah.
Positive plus 1 will always be greater than 1, correct?
Yes.
The least value which I can get is by substituting x as 2. If I substitute x2, 2 minus 2 is 0. Rest all negative values, when they'll be squared, they'll give me positive. Positive values, when they'll be squared, they'll give me more, greater number. The least which I can have is when I substitute x as 2, I'll get 0, and then 0 plus 1 is 1. So this is the range. This is something for all values of A. When A is substituted as 0, the range is coming out as this one. No?
Yeah.
So that means if I'm putting 0, tell me, if I'm putting 0, what will be the answer? Minus 2 square. That is 4 plus 1, 5.
5.
So 0 will give me 5. 1 will give me what? Let me draw it neatly.
2.
0 will give me 2 to the 4, 5. 1 will give me 1 minus 2 is minus 1 square. So 2. 2 will give me 1. 2 minus 2 is 0 plus 1, 1, right?
Yeah.
Rest all the values will be greater than 1. If you take 3, 3 minus 2, 1 or 1, 2. Correct? 3 is also 2. So can you see in onto the values which question has given me that it is moving from something to 1 to infinity. No number will be left behind without having its pre-image. Why? Because the answer is ranging from 1 to infinity. And definitely when you are putting values from 0 to infinity, it is giving you the least value as 1. Rest all will be covered, right?
Yeah.
So because every single value of x is giving me y, which is lying in the codomain, which is given by the question. Hence, this function is on. Is this okay? Does this make sense or not?
Yeah. So basically every value of x is greater than or equal to 0 and every value of y is greater than or equal to 1.
Yeah. So question has given me that for a equals 0, prove that it is onto. So I put it as a0. If I put a0, because this is my x is a, right? Starting from a, this is x. And it is giving me the first value of y. So it is onto. Because every single element of y is being covered for its pre-image.
Yeah.
So you will write that yes, for a is equals to 0, it is subject. So it is such having surjection. Okay.
Okay.
What else? The second part?
But the answer, like the given answer was slightly different. Like they did y equals to x minus 2 squared plus 1. And then when they solved it, they said that there's two options, x1 and x2 equals to 2 plus or minus root y minus 1. But since there's only one that goes inside where y is greater than or equal to 1,
Hmm.
and x is greater than or equal to 0, then x can only be 2 plus root y minus 1. But why can it not be 2 minus root y minus 1?
So basically, if they are writing that, first of all, let me now, if I have y equals x minus 2 square plus 1, and I want to find out the value of x from here,
Yeah.
this is the value, right?
Yeah.
Now, in order to have, because they have defined that x starting from 0 to infinity, right? And we have to prove
Yeah.
that the y value lies from 1 to infinity. So if I substitute, if you want to see where it is not defined, y minus 1 in under root, it should be greater than or equal to 0. Range is this way, right? I told you that in
Yeah.
square root, We cannot have negative square root. So negative means complex numbers. We don't have them. It is about
Yes.
real numbers. So that means y is greater than 1, greater than or equal to 1. Yeah. And
Yeah.
this y greater than or equal to 1 is what? 1 till infinity. 1 is closed interval. So what I'm trying to say, they are asking to prove the surjectivity. So you will say surjective, that is for x, because x will definitely be counted. All the x will be counted. For x, there is an image. For every x, there is an image in y, or we'll call it for every y, there is a pre-image in x. And if there is a pre-image, there must be a defined value. And that when we put this, we get this as the value for y. As it is under the defined terms, hence it is surjective. Every y. If let's say my y would have come by keeping x something, if my y would have come -3, but my question has given me the relation or function from a to b and b is this. So -3 does not belong to this. So I'll say that -3, though it is there in b set, but it is not having any pre-image. So it is not on. Are you getting my point?
Yeah.
What else is written in the answer which you are not getting?
Wait,
Or
so but like it can't be x1 equals to 2 minus and then root y minus 1. Why though?
again, tell me again. X,
x2
you mean
equals
x
to
square?
no x, okay, never mind, just x.
Okay, you mean
X
this.
equals to 2 plus and then in the square root y minus 1.
Yeah.
That is the answer. And then
Hmm.
2 minus square root y minus 1 is not the answer. Why can 2 minus not be the answer?
Okay. Let's say if you want, okay, if you have to, plus minus is are both there. But if your x is defined as this, so it is only having positive values, right?
Yeah.
So positive values you have to consider. If you will be having this one and you substitute any such value, for example, let's say what you want to put y as 1. So what will be your x? This is gone. X will start from 2, right?
Yeah.
So x is starting from 2, but x has to be started from 0 to infinity. And
Well, in
also
this one, x also does not start from infinity, from 0.
from 0, from for first one.
Yeah. How?
But here you have to define x for, see, whenever you solve root, you have both of them. But you need to see which one is satisfying the equation. You have to go from 0 to infinity, and the answer should give me 1 till infinity. Okay. So if you
Yeah.
substitute here x as maybe 0, let's say. So it will be 2 root y minus 1. And when you will
But
bring,
x is 0 is not possible in there then.
you have to
You must
check. So
get a
if you,
complex number.
this is x 2 plus root
Oh,
y minus 1.
so if x is 0,
Yeah, let's see. I need to start y should come as 1. Okay. And when will be y1? When x is 2. Next, is there any x which is satisfying it for negative value also? For example, if I substitute here -1, here also -1. It is -3, but in squaring both sides, we can have it. This will be -3. Is there any chance you can send me those solutions so that I can see what exactly the teacher wants to say?
Yeah, I'll send it right now.
Is there is the teacher saying that this one is rejected?
Yeah, the one that's minus is rejected.
Rejected. What's the reasoning he has given for?
Y has to be greater than or equal to 1. That's
Hmm.
it. And this, like, the first one fits into the domain of F.
Yeah. So this is what I'm saying. So what you do, this is confusing when you are finding out X. And what
Okay,
I
I've
have
sent it.
started via mail.
Yeah.
Okay. The quadratic equation has a general solution in any case, it holds that you're talking about C part, right?
No, part A.
Part A.
Yeah.
But it is not saying that reject the negative one.
Yes, but in the answer, it's only mentioned.
Yeah. Let me tell you that whenever, see, if I come back to this point, it is just saying that proof at A equals 0, that is X, this is surjective. And surjective means it should give me the value. So what you do, you just say that uh, you don't need to assume because Y is already there. So what you do, you substitute any value of A after getting this. You say that on putting values of X belongs to A infinity, the least value is 1, because you can see if I substitute X as 0, sorry, X as 2, it is giving me what? 2 minus 2, 0. It is giving me 1. Is 1. Rest all values are greater than 1, which belongs to this codomain. As all the values are being satisfied with this range, hence this is onto. Okay?
Yeah.
The only thing why they are not considering negative value is because I don't want negative x. The question has given me x for 0 to infinity. Nothing else. Okay? So let's say y minus 1. If I assume minus square root y minus 1 plus 2, it will give me negative value of x also. Will there, if you substitute, let's say y greater than 1 here, substitute. If you substitute, let's say y 10, okay?
Yeah.
Substitute y 10. Tell me what is the answer which you are getting.
-1.
Which is not defined.
Yeah.
I want a to infinity. That is the only reason, okay?
So that's why you take positive.
Yes, because the domain which is defined is this 0 to infinity. You cannot, if this
Yeah.
would have been minus infinity to infinity, then you would have taken the both of the values, okay? Does this make sense?
Yeah.
Okay. What is the next doubt?
Um, so when you do questions to find the surjective,
Yeah.
how do you normally do them?
You simply, so we take the counter examples. If you can find out, there are only two ways. If it is definitely true and you are asked show that, or you are asked check whether. So check whether is dicey. Herein he tried to find out that counter example which will give you y not in the range given. And if it is true, then you will simply write that when once you get the value of y and x in the most simplified form, you simply write that as the preimage of y lies in the domain given, or you do opposite. The image of x, that is the value of y, lies in the range given, hence it will cover all the values of y. No y. So I would say that no y is left without its preimage, hence it is onto. Are you getting my point? This is totally theoretical, and here you have to solve, though you have to come to that value, the same thing which we do to find out domain and range so as to match with the range. Okay,
Yeah.
what else? If doubts are clear, shall we move ahead with the topic?
Um, I was also stuck on,
Mhm.
like, I get the answer, but I don't know how you're supposed to start it for part B of question 1.
Question number one, part B.
Yeah.
Part B is saying determine the smallest value of A such that F is still injective. Okay.
Yes.
So, injective means, injective means, hello Anushka, am I audible?
Yeah.
Injective means what?
It's a one-to-one function.
One to one. So what do you
Yeah.
need for one one?
Um, as in one x should have like another y value.
Yeah. But can you see here you have square? So square is very easy to manipulate. If you have this as y, so you will be having, in if you don't place 2, Because if you place x as 2, you will get exact value 1 because 2 minus 2 is 0. Apart from this, if you put anything, uh, negative 1, positive 1, it will give you same answer, right? But negative 1 is restricted by giving this as the limit, correct?
Yeah.
So if I'm only going to get positive value, then there is no chance of repetition. So I'll say that this is 1, 1. Is this fine? But how do
Yes.
we use the proving part for it? X minus 2 whole square plus 1. X minus 2 whole square plus 1. Now see, in order to prove 1, 1, you always consider let fx1 is equal to fx2. Then x1 minus 2 whole square plus 1 is equals to x2 minus 2 whole square plus 1. This is called subscript. So you can see 1 is gone. Now don't cut it this way that 2 is gone with 2. Do it this way that bring it to left hand side. A square minus b square is a minus b, a plus b, right?
Yes.
So this is gone. So x1 minus x2 is 0. x1 plus x2 is 4. So I have to consider that value for which this is equal. Okay.
Where did the 4 come from? Okay, never mind. But why are you doing, like, why are you subtracting it then equaling it to 0?
So for example, if I have factors, in order to find out the values of x, you have to equate them to the right hand side, the 0, right? Then you will say that
Yeah.
x is 2 and x is 3 for this equation. So every single time, if you get from function, you substitute, you assume fx1 is equals to fx2, and you get this x1 equals x2. Then you will say that yes, hence function is 1, 1. Because for every unique x, so you initially assuming that, oh, these are two x1 and x2. But then you say, no, they are same actually. So y1 and y2 are also same. So for same x, you have same, that unique value of y, hence function is 1, 1. Does this make sense?
No.
Why? Because answer is not coming out as 2, as 2. This is just to prove 1,
That
1.
it's injective, right?
Injective, yes.
Okay. So
In
then when
order,
you
huh, yeah, go ahead.
so then when you solve it, you just do x like you just
You start with fx1 equals fx2 and you
mm-hmm.
bring it down to x1, x2 and you say that it is 1, 1. For on 2,
Okay.
you assume that fx is something, y, express it, find out the value and get the value range for it and say it is on 2. Clear?
Right, yes.
Next question.
But what would be the smallest value of a then?
Yeah, that is, we have already talked about. It is because y is x minus 2 whole square plus 1, as the range of y starts from 1 to infinity. So that means, because it is 1, 1, it will start, if y is starting from 1, the minimum value will also be received by this. So, I mean, not minimum, but the value which from where we can get 1 as y. That will be, if you substitute here 1, so x minus 2 whole square is 0. So x minus 2 is 0, x is 2. The only value which will satisfy it. Clear?
And it's x equals to 2 um because you take the minimum value of y.
Yes. It is saying what will be the value of x for which range of y, minimum value of y will be satisfied. This is the question, right?
Yes.
So this is how you can get it. Is this fine?
Yeah, or you could also draw a graph, and since injectivity is equal to when the graph is strictly increasing, you just take the first point where it's strictly increasing, like the vertex, right? Since
Correct.
it's the
The
parabola.
minimum value. Correct.
Right, I see.
What is the next doubt?
Um, Question number 3, like I see how you do it, but just to clear any confusion.
Okay. Question number 3. For what values, for what, for all possible values for a such that the function, let me paste it there. Fx is cos x plus a is odd. That is f minus x is equals to minus fx. So what do you understand by this question?
Um, okay, well, currently cos x plus a is even. Like
Hmm.
if you take a as 0, just
Hmm.
cos x is even. So you have to take any value of a, like all possible values of a, and make it so that it's actually odd.
Right. So if you do it the same way I've asked you, do you know how to define a function when 4 quadrants are given? Here all are positive in first quadrant, second quadrant sine and cosine are positive. In third, you have the acronym is, the mnemonic is after school to college. So 10 cot, 10 and its reciprocal are positive, rest all are negative in third quadrant. And this is cot, uh, this is cos and sac. Okay. So what happens? This is 0, this is 90, this is 270, this is 270, right? 180 by pi. You know how to change it? This is 180, then 270, and this is 360, correct?
Yes.
Now what we do, if I have sine pi minus theta, pi minus will be the second quadrant itself, so it will give you positive value. Okay, this is
Yeah.
how you can estimate it. Now come back to this. All possible values for a such that this is odd. And odd means if you substitute the negative value of x, it gives you negative of fx, right? And odd
Yes.
is actually, I cannot get it without sign, without the help of sign, right?
Yeah.
So how can I get it? So if it has to be an odd function, then let's say this is the condition. And if this is the condition, what I'm supposed to put? Your fx is actually cos x plus a.
And sine is an odd function. Can't you put like anything that converts the cos function into the sine function?
Yeah, that is doable when we do sine 90 minus theta. That makes it cos theta. We'll come to that. And here, all the domain values are defined in the function. X belongs to all of them. So we can come to that. At the moment, if I take the converse, let's say, so I have to prove, so it is already saying that it is odd. So I can assume that yes, if it is odd, let's find out the value of A. So that means this is the thing, correct?
Yeah.
When is cos in negative?
Uh,
It is negative. Either you can bring it to left hand side and apply. This is what?
2 cos.
X plus A.
Yeah.
Cos x plus A is 0. And 0 it is where? In the multiple of 90. So if you
So pi by,
substitute,
yeah. So
A will
x
be
plus equals to pi by 2. Yeah.
pi by 2 minus x. Okay. And it can be anything, not just this pi by 2. It can be the multiple of pi by 2
Yeah,
also.
so 2k pi, just so you get around the pi, right?
Yes. 2k pi, or you can define k as the odd number. Something like 2n plus 1 or something. Are you getting my point?
Yeah.
This is one way. Or else what you could have done from here, convert it where you can get the theta, the angle as negative. So it is negative cos x plus a. You know that cos, this one is positive for cos, fourth quadrant is positive for cos. You can choose anything. You can choose pi minus or pi plus or 3 by 2 3 pi by 2 minus. Everything will put you back in what? Second and third quadrant, right?
Yeah.
So if you write anything, for example, pi minus theta, this is cos x plus a, and you can write it cos theta minus pi or pi minus theta. And then you can, as cos is there, it's gone. Pi minus theta, pi minus x minus a, 2x, pi minus 2a. X is pi by 2 minus a. Are you getting my point? No,
Yeah.
we are supposed to find out a. So a is pi by 2 minus x. Again, the same thing. Clear?
Yeah.
What else?
So then the answer is just x equals to pi by 2 minus a.
So I need to find out a. So a is pi by 2 minus x. And you will say that, assume that this is k. K is the odd power.
But you can also just say 2k pi plus pi by 2 minus x, right? Like you, that would just
2k
get you
pi.
the same.
Perfect. Perfect. Yeah. We can say the same. But then remember, okay, let's say 2 is cancelled and you are left with k pi.
2k pi plus pi over 2 minus x.
2k pi plus pi by, yeah, that is workable. So that's what I'm saying. If you can
Okay.
put it as odd power, you can have it as 2n plus 1. So this will also, you know, you can have the LCM and thing. It can also be turned into this form, correct?
Yeah.
Any other question?
I think question number 4 as well.
Question number 4,
Yeah.
the piecewise function.
Yes.
Okay, let me. It is saying sketch the correspondence graph. Now you are given with the absolute function. And that too in the interval -1 to 2, right?
Yeah.
So what do you think we should start with?
Um, don't you first have to like write the definition, like the piece of the piecewise function?
Yes, if
So,
we have modulus, if absolute value, we know that even if if x is greater than 0, you substitute it minus x. If x is greater than 0, you substitute it x. And if x is equal to 0, you substitute it 0, right?
yeah.
So these are the values. So similarly, for this one, what you will do, if x is less than 0, you will write this as minus x, this as minus 2x minus 1, right?
Yeah.
Then if it is what? Greater than 0, then you will simply write plus. And if it is equal to 0, how much is it? Minus x minus 1. How much is it? X plus 1, right?
Yeah.
Minus minus 2x minus minus plus 1. So if you open this bracket, it will give you plus 1. So these are two values. Now, what is left? There can be the chance if you do them separately. If you take 2x minus 1, so x is 1 by 2 also, right?
Yeah.
You have two values. If you put x 0 and if you put 2x minus 1 0, so you have on the number line 1 by 0, 1 by 2. So you have interval which is less than 0, 0 to 1 by 2, and 1 by 2 greater than 1 by 2, right?
Yes.
Because these are equal, so you will be having equality also. This is fine.
Yeah.
So you will be having all these values in order to substitute here. Tell me if it is between 0 to 1. So this is done greater than, less than. It should be less than 0. Then it should be greater than 1 by 2, the last final piece function. And the middle one should be 0 to 1 by 2. Correct?
Yeah.
So in middle one, what should I get? The number 0 to x. I mean 0 to 1 by 2. Assume any number. Consider any number. What do you think? Which will give me negative answer? X will give me positive. I'm not talking about absolute value. Just forget about absolute value. Consider the inside function, x. And here it is 2x minus 1. If I place x as half, let's say, or let's say less than half. What is less than half? 0.25. It will give me what? Negative value?
But why do you take 0.25?
Because I need to consider value between 0 to x, 0 to 1 by 2, less than half. If I take exactly half,
And
then it
why
will
is
give
it
me,
1 by 2?
because I just solved it, no? For different function, I have two absolute value function. If I substitute this as 0, I get x1 by 2 and this as
And
x0.
okay, so 0 and 1 by 2. And it
Yeah.
should be between -1 and 2. So
Yeah. So I have
is it
three
like
value number.
-1 to 0, and then 0 to 1 by 2, and then 1 by 2 to 2? Is that,
1 by 2. Yes, perfect.
and
Later
why
on,
is there options?
sorry.
And is there three options because you have 0, 1 by 2, -1, and then 2. And that's just how you fit all the intervals in each other.
At the moment, you will write for all the intervals like less than 0, 0 to 1 by 2, and 1 by greater than 1 by 2. Later on, when you will draw the graph, you will convert them into the values like -1, which is less than. So it will be -1 to 0. Then
Yeah,
here 0 to 1 by 2, it will remain same. And here it will be 1 by 2 to 2. Later on, when you will start drawing the graph by plotting, by considering the points. But at the moment, you have to write it for all. So you will see that if you substitute value less than x, this will be minus x. This will give you minus value. Similarly, if you consider anything greater than 1 by 2, so x greater than 1 by 2 give you plus. Here, 1 by 2 greater than 1 by 2 will give you plus. So minus sign is the question. Then 0 to 1 by 2, if you substitute anything, like if you substitute x as exactly 1 by 2, I can't take because it is giving me 0. I'll not be able to find out whether is it negative, positive. So I'll substitute something else, maybe 0.25, right?
yeah, yeah.
It gives me negative. So x is positive and this one is negative. Okay? Negative for this function. Is this fine or is this hodgepodge? You're not getting it.
No, I think I get it. It's just
Hmm.
like how do the signs change each each part changes?
So basically, we are defining the x here, the limit for x here. Final answer will give
I
me
think
something
you can
else.
erase
Huh?
I think you can erase what's written because I understand it, and otherwise it'll get hard to read.
Okay, you want me to write it neatly?
Yeah,
Okay. So it is fx is equal to x minus 2x minus 1. This is the question. Now, I need to define this function for certain discrete value. What those discrete value will be? So you put them the function as 0, the separate function. These are two different modulus function. So one is 0 and this gives me x1 by 2. So that means if I draw it on number line, it is giving me minus infinity to minus infinity to 0, then 1 by 2 and then 1 by 2 to infinity. So I have one function less than 0, another function 0 to 1 by 2 and another function 1 greater than 1 by 2, right?
yeah,
And I'm considering equal sign also. Now, if you are considering anything x less than 0, just define it without modulus sign. You will get negative x for the values less than 0. X is negative. So negative x, what you will
yeah.
put inside the modulus, negative x. Minus is in the formula.
And why is it negative x? Just um yeah.
If you find out, how will you define that which value you are putting into? So minus 2, how will you define that x is minus 2? You will say that I'm putting in minus value here.
Yeah.
And for this one, 2x minus 1, if you place anything less than 0, let's say minus 1, place here -1. So -2 -1, it will give you -3.
Yes.
So it is also minus for x less than 0. Okay.
So they're both negative.
Yeah. So minus minus plus, that
But
is,
if the domain is -1 to 2,
hmm,
then you can only take values that are between 0 and -1, right?
yes, that will come to it. This is one. Then secondly, we have what? If I
Um,
say 0, so 0 will give you here what? Positive value. So basically not exactly 0, but you are taking 0. This will not have be having equal sign because equal sign is considered here. So you are having x, just bear. Next value is x lying between 0 to 1/2. This
yeah,
was for first one. Now for second one, if you substitute anything between this, let's say 0.25, it is 0.25,
it's
so plus
positive.
x,
Yeah. And then this
this
one is negative because
negative.
it's still negative. Yeah.
So x minus minus plus. So what is it? 3x minus 1. And then third one is greater than 1/2. So if you substitute greater than 1/2, it is plus x. Anything greater than 1/2, maybe 1, 2 ones are 2. It will give you plus, right?
Yeah.
So this is, so I have these three functions. Now I need to plot them. What you do, you plot them. You first take only which part? This one. X, and in place of y, you have minus x minus 1. Then you take x, then you have 3x minus 1. And then you plot another table, x minus x plus 1. But remember that for these x, you have to take values lesser than 0. For this, lesser than, only lesser than, not equal. For this one, 0 to 1/2, and for this one, greater than 1/2. Is this fine?
Yeah.
So if you take any value, for example,
And
less
since
than
they're
1,
both, since like everything is linear, then it will just be a straight line from those points that we discussed, like from -1 to 0, 0 to half, half to 2, right?
it will be in bits, something like this. Straight for one interval, straight for one in another interval. Are you getting my point?
Yeah. 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 Yeah.
So this is how, and then you just explain from, or maybe color it with some different color, that -1 till 2. This is lying from here on there. Is this fine?
Yes.
So any other doubt?
No, I think that's it.
Okay. So, um, all right. Let me know when do you want the class. So next class is probability, right?
Yeah.
Or do you want to continue with this one?
No. I mean, my test is tomorrow anyway, so I'll do a bit more practice of trigonometry and everything before I stop.
No problem.
My only
See you
problem
with,
with trigonometry is when do you write the other solutions, but I think I'll figure that out, so it's fine.
if you want, I can explain you now, or you will manage.
Um, Okay, yeah, because there was like this one question in the worksheet. It wasn't hard, but we can use that as an example. It's it's just question number 10. It's not exactly like what I struggle with, but this will be more relevant.
Okay. So it is what? Arc
Uh,
sine 1 by 3. How do you approach it usually? What exactly you are
basically put it
facing the
in terms of
difficulty?
sign.
Yeah.
Like you put it in terms of sign and then you solve it.
Hmm. Okay. So for example, if you have uh another one, alpha arc sine 1 over 3, and you have to find out every other thing, cos alpha, tan alpha, sine 2 alpha. So here you arc means sine inverse, right?
Yes.
And then you change it, sine alpha equals 1 by 3. Now what you do, you compare it with the, do you have any acronym for this? Okay, how do you learn this trigonometric ratio? Is it adjacent, opposite, perpendicular, or perpendicular, hypotenuse, base?
Um,
Basically, sine is perpendicular upon hypotenuse.
yeah, so it's opposite over hypotenuse.
Okay, I got you. So, SOHCAHTOA you have learned, right?
Yeah.
Okay, so you remember that. Sine
Yeah.
alpha is perpendicular upon hypotenuse. That is opposite upon hypotenuse, right?
Yeah.
So once you get that, draw a triangle, consider anything as alpha, not, I mean, angle other than 90. And then it is, so opposite, perpendicular is 1. I know we cannot exactly take this because if I have 3 by 9, then also this is just the ratio, right? It is not the exact figure, exact value. But there are two ways of doing it. Perpendicular, you can assume 1. Perpendicular is opposite. Hypotenuse 3. So what will be your base by Pythagoras theorem? You know hypotenuse square is equals to opposite side square, perpendicular square plus base square, right?
Yeah.
So hypotenuse 3, perpendicular is given. Base, I don't know. 9 minus 8, 1 is 8. And 8 is this. 2 to the 4 to the 8. So it is actually 2 root 2, right?
Yes.
So now I want cos alpha. Cos alpha is adjacent base upon hypotenuse. Adjacent upon hypotenuse, right? Do you know that?
Yeah.
So adjacent is this 2 root 2 upon 3. And then tan alpha, I know the formula for tan, sine upon cos, right?
Yeah.
Or you can do opposite upon perpendicular, upon base also, like adjacent. So opposite is, which way do you want to do? Sine alpha is given 1 by 3. And this is 2 root 2 by 3. 3 is cancelled. So 10 becomes 1 by root 2 root 2. Is it fine?
Yeah.
So if 10 is this, 1 by 2 root 2, what are we asked? Sine to alpha. I know the formula for sine to alpha. It is 2 sine alpha cos alpha, right?
Yeah.
Sine alpha is 1 by 3, cos alpha is this. So 2 to the 4 root 2 by 9. Okay?
Yes.
Where do you exactly stuck? Does this answer your doubt or not?
It does. It does.